Hello, I'm Jackson. I'm with AJ's 2026 Deep Group, and I'm showing the quantum entanglement demo. So what we're doing in this demo is we're showing some basic principles of quantum mechanics, such as entanglement, complementarity, and a little bit of what we do as physicists in a laboratory setting. So what we're doing here is we're shooting a laser into a setup that enters a special kind of crystal and then a camera. What's interesting about this crystal is that crystals have a regular geometry, so they have a lattice-like structure. This crystal in particular has a coaxial symmetry, which means that occasionally when photons hit it, they have a chance of splitting into two photons of equal energy, one half of the original. Additionally, they have a chance of being entangled. And what it means to be entangled is that no matter how far apart we put these photons, they could be light years apart. The moment we interact with one of them, we automatically and instantaneously interact with the other one. And then, once we shoot the beam into the camera, what we're seeing here are cones where these entangled photons might be. So you might be thinking, can we find the entangled photons anywhere on these cones? No, we cannot. We can only find them at the intersection points here and somewhere down here. And what I mean by these cones is when we split the photon into two, by conservation of momentum, they have to split in equal and opposite directions. And since we live in 3 dimensions, they can split in a whole cone. And since there's 2 photons, we have 2 cones for each one. And that's what you're seeing here on the camera, is a cone for each photon that splits off. But you'll only ever find an entangled photon where those cones intersect. And that's a bunch of mathematical background that I don't go into, but that is the general idea of how we find and produce entangled photons in a lab setting. And the reason we're showing this is to give you a basic idea of some of the more applied concepts behind quantum physics and what we do with it in a lab setting. But yeah,